associated with the pre and the post gyri on each side of the sulcus, because that is how the body is going to handle the information. What? Huh? Ever heard of homunculus? Little man. Alright. This is representative of areas of our body. Does everybody follow me? You see, like the face, the nose, the lips, all that sort of stuff. So, if I'm looking at my brain and my central sulcus, and I have the post and the pre-gyri, all right, sensory information must come into my sensory gyri. This is how the brain picks it up. Couple of things, all right? So, if I'm in my little gyri, it's showing representation of all areas of my body. How much of the cortex is used by simply my face and my hands and my feet? Tongue, lips, teeth, nose, face, thumb, hand, wrist, shoulder, right there. All of this is given to sensory information from simply my face and my hands. Why? That's where we get most of our information. I'm getting most of my information, first of all, from my special senses. Alright? And I'm getting a lot of information from simply things I'm doing. Do you notice anything else about the orientation of homunculus into the sensory information? Is he right side up or upside down?
A little bit of both.
No, he's upside down. Meaning, information from my feet has to go the farthest. It has to go to the furthest point of that gyri. So that information, this sensory information, gets to be associated and processed in these other areas of the brain. So if it gets to be associated and processed, we're going to have information that went in get a response. So if that was my if that was my sensory, I've got to have areas for motor. So if I have my pre and my post, those two gyri, pre is for motor responses, meaning it's going to go to a muscle or a gland. So the pre is my motor cortex. We're going to find that we're going to have association areas, and then we will be able to get responses? Is there something we need to plan? Are there movements we need to make? Are there emotions I need to modify? What mood is going to need to be modified? So if we look at my pre-gyri, because this one was the post, okay, if I got pre, now what do you see about little man, the homunculus? Once again, he's upside down. Feet have to go to the farthest area. How much of it is being utilized for basic units? Okay. It's almost like if we were built to size, okay, it would be it would be tongues that were huge, hands that would be huge, feet would be kind of big, legs would be very, very tiny, arms would be very tiny, chest wouldn't be very big, head would be big. So we're not built to the size of the information that it's actually receiving and giving responses to. But this would let us know, all right, well, we've got an area of the brain that sensory information comes into, gets processed, and then we're going to have areas of the brain that are going to have to give responses to the information that came in. A lot of the information that we deal with comes down to what is going to be the control of skeletal muscles. It's information about whether you're going to write notes, whether you are going to get up and walk, whether you're going to move, whether you're going to turn around in your chair. Because our skeletal muscle system, notice which muscle I'm referring to, the skeletal muscle. Wow. Reflexes, posture, facial expression, speech. We're going to have part of voluntary, involuntary. The reflexes are not counted as voluntary. That is something that you do. It's an automatic response. For the most part, we say skeletal muscle system, voluntary. Consciously doing something to achieve your goal. You guys remember upper, lower neurons, all right, where we have like the neurons that'll synapse in the thalamus, and do you remember those? Upper and lower and that sort of thing. It's controlled by two of them. It's controlled by the upper and the lower, because information goes in, it synapses, goes up the spinal cord, goes to the brain, we get a response which comes down and goes out to the effector. And for this case, that would be a skeletal muscle. So at this point in time, from the anatomy that we have looked at, the spinal nerve that exits the vertebra, our cranial nerves that will exit by way of the brain, their job at this point, affecting skeletal muscles. Is that the only muscle that we have? No. Okay? So at this point in time, effectors, meaning they're carrying out the responses of information that's going in, we are learning them in reference to skeletal muscle. Next chapter is going to bring us something different. So, we're going to see that for skeletal muscle, most of the voluntary movement that you intend to do, it begins in premotor areas to the front, all right, of that cortex, and it stimulates an upper motor neuron. So as everybody's looking at the clock, okay, I see it. As you turn your head to look at it, as you're waiting for me to say, go take a break, you're already thinking about moving the muscles that are going to be needed to get up out of the chair. And because of that, it's already stimulating the neurons in the upper motor area. So you're stimulating those neurons. That stimulation is going to travel down the descending nerve tracts to a lower motor neuron, which will travel to the skeletal muscle.
Is that stimulation anticipation?
Yes, but that's only occurring in this frontal area. It's not occurring elsewhere because the frontal area is for planning an activity. So that voluntary movement of the muscles doesn't occur elsewhere unless it's a reflex. If it's a reflex, it's synapses and the spinal cord only. Because we have a connection between our basal nuclei, which are close to the brainstem, and nuclei of the cerebellum, which is responsible for about 85% of our balance and coordination, you're able to take a break and be back at 9:30.